First question comes from section 8.3, number 25, on page 564. So the directions for this particular problem, we want to use point-slope form to write the equation in the line, passing through the two given points and solve for y. So with this particular problem, what you want to do is, if you have it in point-slope form, that means that you're going to use this setup of y minus y1 is equal to m times the product or the quantity of x minus x1. So from here, what you want to go ahead and do is you want to figure out what information you have. Okay, so the first thing that we have, we need to know what the slope is. And then we also want to know what coordinate point I need. So hence the reason why this is called a point-slope form. Well, the first thing that we need is the slope, and it's not explicitly given to us. So what we're going to have to do is we're going to have to figure it out. So what I would suggest doing is identify which point will have your x1 and y1 and which one will have your x2 and y2. So in this case, we would do negative 3 minus 4 all over 0 minus 3. If we were to solve for the slope, we would get negative 7 over negative 3. But bear in mind in this case that we have a negative over a negative, so this simplifies to a positive 7 over a positive 3. From here, we actually have enough information to take care of this. So what I want you guys to be aware of is we just plug this value in. So we have y minus, and you can really pick either the point that you have for p or the point that you have for q. So I'll demonstrate why this makes sense. So we do y minus, in this case we would use 4 if we're using point p for this problem. So we do y minus 4 is equal to 7 over 3 times the quantity of x minus 3. Okay. Now, the second half of the problem is asking you to solve for y. In other words, they want you to get y on one side of the equation completely by itself. So in order to do that, another way that you guys can think of it is basically they're asking you to go ahead and get this into slope-intercept form. The whole goal of this particular problem is they want you to be able to see that point-slope form is connected to slope-intercept. They're not two completely different entities. They're actually the same thing. So from here we would want to remember to distribute that 7/3 to both of the terms inside of the quantity. And then this becomes 7/3 x, and this becomes minus 7. We would add 4 to both sides to get y completely on its own, and this gives us y is equal to 7/3 x minus 3. So again, let's take a look at this problem again, but this time let's go ahead and solve this for using point Q. Okay, so in this case we would start it off and go y minus a negative 3 is equal to 7 over 3 times x minus 0. Okay, so I don't know if you guys can already see it, but there looks like that there are pieces that are already kind of coming forward. Do you guys see that the 7/3 is still there? And do you guys also see that there's a negative 3 in our problem over here? So if we were to continue to work this, we would have y plus 3, because a negative and a negative together will make that a positive. And then we just have 7/3 x, because x minus 0 would just be x. If we subtract 3 from both sides, this also results in y is equal to 7/3 x minus 3. So again, the whole goal of this problem was to show you that when you're working with point-slope form, ultimately, once you convert it into slope-intercept, you're going to get the same value out.